Welcome to CS50 Week 6. This week we're moving from C to the world of Python. I'm Kelly. As you may or may not know, I'm the preceptor here at Harvard. I'm excited to go through this section with you all. So like I just mentioned, this week we're going to be moving from C to a new programming language called Python, which you may be familiar with. And as you saw in yesterday's lecture, there's a lot of different benefits to Python, differences compared to C. And so we'll dive into some of the new syntax today, as well as some of the reasons why we're using Python and the benefits that it allows us to use. So just some initial differences between the two languages. C is called what we call a low-level programming language, while Python is a high-level programming language. And what this really means is just that Python has abstracted away some of the things that C has implemented, as Python is really just built on top of C. And so some of these things like manual memory management, like you were doing with pset4, with mallocing and freeing memory, that is not dealt with in Python. In Python, memory management is automatic, and so it's not something you have to think about or deal with, especially as it can cause a lot of issues when you're working with memory. And so Python likes to abstract that away, and though it might give you less abilities to work with memory, it's typically safer. And in C, another difference we notice is that you have to declare types pretty explicitly, saying when you're declaring a variable that's an integer or a character. In Python, the syntax you'll see is much more human-like, and so the variables are dynamically typed. The interpreter figures that out. So feel free to drop it in the chat if you have any questions about the differences between C and Python. But I'll pose a question, perhaps from a pedagogical standpoint. Why might you think that CS50 begins with teaching C rather than diving right into Python? I'd love to hear any thoughts in the chat. Yeah, someone says it's better for teaching fundamentals. Yeah, so C is, as we said, low level. And so a lot of the things that you can do very easily in Python are harder to implement in C. But that hardness really gets you to think about the intricacies of what your computer is actually doing. Yeah, it's what is really happening in the computer, exactly. Yeah. So now that we're at this later point in the course and you have a better idea of, pointers, how memory is managed in your computer, we're able to kind of abstract that away and move to more higher level problems and doing that with Python. So let's get into some of the syntax that is new with Python and how some of the structures we've seen before might differ. So to begin with, we saw this char star name equals get string statement quite a bit, where we're trying to get perhaps a name from the user using our CS50 library's get string function and storing that in a char star, which we also know to be a string called name. In the Python version, we see just name. So we didn't have to specify the type anymore. Python is smart enough to know that when you're getting an input, that's going to be stored as a string. And then we also don't need to rely on the CS50 library if we're getting text, as we can just use the input function. You can also note that there's no semicolon anymore, and that's just another small syntax thing that is different in Python. Another difference here, so you may have seen, was In C, we had to use this string compare function when we wanted to compare two strings, right? As we know, we might have some variable, a string variable in name, and then maybe we're trying to compare that with the string Alice. And so in C, does anyone remember why were we not able to just compare that directly using the double equal sign? If I just did if name equals Alice, why might that not work? So since we learned that strings are actually just, a pointer to a character, right? So it's like a string is a sequence of characters or an array, and yeah, exactly. So when you're comparing them literally in C, it's going to be checking only for that first, for that address, rather than actually whether these two strings all the way from the first character to the null character are equal. And so that's why we had to use string compare to do that. While in Python now we can actually just literally use the double equal sign as we kind of intuitively would think to, where we can just do if name equals Alice, and then we have a print statement. So some other differences we can note syntactically. We don't have this curly brace situation anymore. So when we want to indicate that something is happening within a code block, so only print if name equals Alice, this indentation now becomes really important. So the only way for Python to know that this is what you mean to happen only if name equals Alice is that it's actually indented. So style here is going to be really important. And yeah, another difference here we can see is printing. Our printf function has now just become a print function. However, we do have some of this formatting going on here in Python, where we've indicated we're going to print a formatted string by the f, and then with the formatted string we're able to use these curly brace notation in order to use name as sort of a placeholder, similar to what we were doing with the %s, and it sort of just substitutes name for that place. There are other ways you can print this as well. You can do some string concatenation, where you do like quote hi, comma, plus name. And so Python allows you to, it's pretty flexible in that it gives you a lot of different options for doing printing and concatenating strings and working with strings. Okay, so moving to lists. Lists in Python are probably most akin to arrays that we saw in C. But we also have some pretty key differences. So first of all, we can see the differences between C and Python. We don't have that type declaration, so we don't need to say that this is an integer list. And not only that, we actually in Python are not limited to only one type in your list. So for whatever reason, if you want to store multiple things of different types, you're able to do that in a Python list. You also don't have to specify the length here, as Python knows that it's a certain length, but this length in Python is not fixed as it was in C. And so we actually have these functions that we can use, like .append, where we can append something to the list. You can also remove items from the list. And yeah, so this list is actually more dynamic than a C array. And you might think about like, how is this Python list actually implemented? Is it implemented as an array or something else? So what you might realize is that it sounds a little bit like what we were doing with linked lists, where things are connected via pointers. And so if you dive into the Python documentation, if you're interested in seeing, a Python list is not implemented like a C array, because you can see that it has this dynamic property of being able to add to the list and remove things from the list. And so that's just an interesting thing you can look into if you're interested. Okay, next we're moving on to loops. And so with loops in Python, they're much less, at least with for loops, we have a lot less of that syntax where we're declaring a counter variable, and then we're specifying how long, what condition it should repeat until, and then it's the incremental step. In Python, we have this for I in some list syntax. So I, or whatever variable you choose to put there, sort of acts as like your counter variable, as you would have in a C for loop. But now this in list syntax, it's really gonna assume I is the first item in the list, then the second item in the list, then the third item in the list. So in this example, we would see it would be printing 0, and then 1, and then 2. However, we can see that like if we were trying to just use this syntax for a really long list, that might get a little bit tedious. If I wanted to repeat this not just 3 times, but say 100 times, then would I have to write a list that's 100 elements long? Like that seems a little bit tedious. And so we actually have range, which is a function that solves that problem for you. And so this now does the exact same thing as the code we just saw. Range is a function that creates a list from, by default, 0 to 3 exclusive, so not including 3. So range actually can take in multiple parameters here. As we saw before, we just had that 1, 3 parameter, and we were using the default values of range. So it's assumed if you don't input all 3, or maybe you only input 2, that the first parameter is going to be the starting value, inclusive, so starting at 0. And then by default, the step, which is that third parameter, is by default 1. So this range 0, 3, 1 will do the exact same thing as range 3, since that 0 and the 1 are by default assumed. However, if you wanted to, you could also, so that start is inclusive, the end is exclusive, and then this is the step. Yes, and so we can see in comparison to the C code, we sort of have the same structure going on, where we're specifying some sort of counter variable I, and then we have some condition, so I is less than 3. In this case, we're saying this list will go up to 3. And then the increment, we do I++ in C, but in Python, we can indicate that that step is going to be stepping by 1. So to summarize, all 3 of these for loops will do the exact same thing. We're looping 3 times. And there are many other ways that you can loop 3 times. But these are just 3 ways that if you wanted I to be equal to 0, and then I to be equal to 1, and then I to be equal to 2, that's what you would see here, printing 0, 1, 2 each time. Okay. So this is like the typical use of a range function. So something like for I in range 3, you might see that a lot. However, because of these default values, because you can change them, you can also do some funky things, creating different kinds of lists. So to practice, let's take a look at this and imagine what each of these range functions will output as a list. So as we just talked about, range 3 is going to equal the list 0, 1, 2. Starting at 0, going up to but not including 3, and the step each time is incrementing by 1. So if you want to drop in the chat what you think each of these ranges will look like. Yeah, so someone put for A, that will be 0, 1, 2, 3, 4. Exactly. So we're starting at 0 and then ending at 5 exclusive, so up to 5. And since we didn't specify that start value and the increment, those are by default 0 and 1. So we're incrementing by 1 each time. So for B, this is where it gets a little bit trickier. We're starting at 1. We're going up to but not including 3. And we've specified the step this time as 2. So as some people are saying in the chat here, we would print out 1, or so our list would include 1, but then on the next increment, we're going to 3, but 3 is outside of our range, right? So 3 is exclusive. So B would just be a list of 1. For C, some people, are saying we are starting at 5 now, and then we are going until, but not including 0. And each time our step is -1. So rather than increasing 1 each time, we are decreasing by 1. So it would be 5, 4, 3, 2, 1, and not including 0. For D, sort of similar to B, we have starting at 1, so we're going to print, so the list will include 1, and then it increments by 2 instead, so it would be 1, 3, and then 5. It wouldn't print 7 as that's outside of our range. Okay, great. So thanks for your participation on that. Let's talk a little bit about while loops. And so while loops syntactically are pretty similar. We don't have too much of a change like with for loops. We still have this while some condition is true. Again, we see that rather than using our curly braces, the indentation here is really what makes it clear that this block of code is running within our while loop. Another key difference here we can see is that where we could do n++ in C, that's no longer a functionality we have in Python, and so we have to use the plus equals notation. So n plus equals 1, we'll just add 1 to n. Okay. So another interesting functionality that Python has is string splicing, as we call it. And so if we recall, strings are just an array of characters, and so we can treat it as such. If I have some phrase equal to wahoo, then getting the 0th index of that phrase would just be the character W. And then we can use sort of this string splicing notation similar to range to specifically get certain parts of the string. And so in this example, we have 1 is the first parameter, and that first parameter indicates the start inclusive, and it's 0 by default. So if you don't specify the first parameter, then it will start at the very beginning of the string. Then you have the end, which is exclusive, just like we saw in range. And if you don't specify this parameter, then it will be the length of the phrase by default. So it'll go up to the end of the string. Then we have the step, which is also 1 by default. So it'll go character by character unless you specify otherwise. So in this example, we saw it would start at the character at the 1 index, which is A, and then it would go up to, but not including, the 3rd index. So this would give us A and H. Okay, I'll pause here. I just went over a lot of new syntax, but what questions do people have about loops, string splicing, new syntax in Python? All right, well, if you do, feel free to put them in the chat. Okay, so a few more functionalities that we have in Python parallel to C. So in C, we were including libraries, like we remember. So CS50.h was one of our libraries that we included. In Python, we can do a similar sort of thing, but we have sort of 2 ways of importing things from a certain library. You could just import CS50 itself, and when you do so, you would then have to specify, when you're using some sort of function, you would use this dot notation where you have CS50 dot get int, and so that would be how you would call that function. Or if you know exactly what function you want to import, then you can use this syntax on the right here, from CS50 import get int. So we'll see an example of this very soon. Okay, and then creating our own functions. In C, we remember that we have this syntax where we first specify the return type, and then we have the name of the function, and then we have the input parameters with their type. In Python, we use this keyword def, so to define the definition of a function, and then we give it the name and the name of the input parameter. And so we don't have to specify its return type or its input type anymore, since those will be understood by Python. Okay. And then we also had some functionality with command line arguments. So in C, we were able to get some sort of input from the user at the command line. And we can still do that same thing with Python, but we are instead going to use this sys library that we're importing. And so, as with in C, we had argc and then char star argv. Sys does not have in Python a direct equivalent to argc, which is the argument count. However, we can still very easily get the number of arguments by just taking the length of sys.argv. And so, as I was just saying with importing libraries, if I just imported sys and I wanted to use argv, then I have this notation here, sys.argv, to get that. Okay. So now we're going to do some practice. I've opened up and downloaded this string prediction file. And so we're going to predict what string comes out when we do some manipulation to it. Okay, so let's move to cs50.dev. I have created beforehand a string prediction folder. And so let's just open up round 1 here. Okay. So we have phrase equals input give me a string. So we're getting some string from the user, and then we're printing it out in some sort of way. So take a look at this and try to see for yourself what is going to print, or which part of the string, I should say, is going to print. Okay, so we can talk about this together. So with our range function, we can see takes in as a starting value of 0. So that means, okay, we're going to start at the first letter, and then we're going to go until the end. And then our step count is 2 rather than 1, which means it's going to go every other letter, right? So if I try this out, I do Python round 1, Python round 1.py, and let's say I give it the string cat in the hat. Okay, so we see that it has given me that first character, and then it increments by 2 each time. So rather than giving me printing out A, we instead print out T, and then skip the space, I, and then H, and then space, and then H, and then space, and then A. So based on whatever string I give it, if I did just say string, then it would give me every other character. Okay, so let's try out the next one, round 2. Okay. Oops. Okay, take a second now to take a look at this and see what you think this string will give us. Print it out. So if you notice here, we only have 2 parameters in this range function. And so that first one is the start, second one is our end exclusive, and then our step is not specified, which means it's by default 1. Okay, so let's try this out. 2.py, and I'll give it the string, say, elephant. Okay, so what happened here? We didn't print out the last character, as someone said. It seems we're also missing that first character, since I started my range at 1 rather than 0. Okay, great. Let's move on to round 3 now. Okay, so this syntax is a little bit different here. We have for character in phrase, print character. So what is this code doing? Yeah, so it's going to print out the phrase, and it's doing so by printing it out character by character. So character is this sort of our I that we've been calling, or like our counter variable or iteration, and it will assume the first character and then the second character, then the third, and it will print each character. So we should see that when we give it the string elephant, it'll print out exactly the same thing. However, we saw that it's not printing out the string directly. Instead, we're iterating, printing character by character. Great, okay, so let's move on to round 4. Okay, so here we see a little bit of our string splicing notation. So again, we have for character in phrase. Yes, but then with this phrase, I've specified our start as 1 instead of 0. So we're going to start at the character at index 1. And then this colon indicates that the rest of my parameters should be the default. So by default, it's going to go till the end of the inputted string, and it's also going to by default have a step count of 1. So if I test this again, round 4, with the same string, elephant, we see that it prints out the whole string minus that first character. Okay, let's do round 5. Okay, here we're using a while loop. So we have some I value variable that we've set to 0. And then while that I is less than the length of the phrase, we're going to print the ith character of the phrase and then increment I by 1. Okay, yeah. So some people have already pointed this out, but this is going to print out the same phrase. We were just doing it in a different way again. So we have some I value that is assuming 0, and then it's going to iterate and increment 1 by 1 until we get to the length of the phrase, except it won't be the last, it won't ever equal length phrase, since that is the end of the string. So if I run round 5, we should see that it just spits out exactly what I give it. Awesome. Okay. So now for round 6, we have a bit of a challenge here. We want to be able to reverse this phrase. So if I give it, say, cat, it prints out TAC. And so we want to do this only by changing the arguments of the range function. So how might I do that if I wanted to print out reversed? So what should the range function begin at? What should be our start value? So we want to start at, some people are saying length phrase, and then we want to go until, some people are saying 0, -1. Okay. Well, let's try this out and see if it works. Okay, so we got some error here. We have on line 6, string index out of range, phrase I. So why is that happening? Any ideas? Yeah, so someone's suggesting, okay, maybe instead of starting at the length of the phrase, we should be starting at the length of the phrase -1, right? So if my phrase is, say, 3 characters, if I actually try to begin at our index 3, that is going to be out of bounds. And so that's why we see this out of range error here. Okay, let's try this one more time. Elephant. Okay, so we see it's going backwards, but I'm missing that last character. Why is that happening? Yeah, so someone's suggesting changing this 0 to a -1. Right, so it's not printing the 0th character because when I specify the end as 0, that's exclusive. So it's not including 0. It'll just go from whatever my length is down to 1 instead of to 0. So if I change this to -1, then hopefully we should see around 6.py that gives us what we want. Okay, great. So feel free to put in the chat if you have any questions about this exercise. But this was just a practice, getting used to the new for loop syntax, while loop syntax, and also playing around with some strings. Okay. Okay, so now we're going to move on to some of the new functionalities that we have in Python, one of which is a thing called dictionaries. And so this is a new way for us to store some data. And let's maybe consider I'm trying to store some songs that I really like. And one way I could do that is, for each song I have the song's name and the tempo in its own variable, but that might get really hard to keep track of, especially when I start to get more than one song. And so a dictionary is one way of storing this information, where we are storing keys associated with values. And so we have these key value pairs that we're storing in a dictionary. And so for this song example, we have a dictionary called song, and it has the key name associated with a string called perfect, and then the key tempo associated with 95.05. Okay, so we can kind of visualize it like this, where we have our keys on the left associated with the values we have on the right. And so if we wanted to get a specific value from my dictionary afterwards, then this is the syntax you would use for that. You have song, which is the name of the dictionary, and then these square brackets, and then the key. So if I use the key name, then this will return perfect. Similarly, if I use this notation, I can also update the values in my dictionary. So if I had this line of code, song with key tempo, and I set it equal to, say, 100, then it would update the value in the dictionary. You can also use the syntax to add new key value pairs to your dictionary. So Python's very flexible in this way. If I specified a new key that doesn't exist in my dictionary already, and a new value associated with it, then it will add that to my dictionary. Okay. We also have some helpful methods that come with dictionaries. And so if you did songs.keys, open close parentheses, that would return to you a list of the keys in the dictionary songs. And then similarly, if I did .values, that would give me a list of all the values in the dictionary song. Okay, so having one song is all well and good, but it's not that powerful yet. And so where this really comes in handy is if I'm storing it in sort of this list of dictionaries. So let's say I have 4 songs now, and these 4 songs are stored in a list, just as we've seen before. I could have a list of 0, 1, 2, 3. I can also have a list of 4 dictionaries instead of like integers or floats. And within each dictionary, we see that I have the same keys and values, which is part of what makes this powerful. Okay, so given I have now songs as a list of dictionaries, how might I reference the tempo of wolves? So let's say I know that this is, say, my 3rd element in the list. Feel free to suggest in the chat, how would I get the tempo of the 3rd element in songs? Okay, so we're seeing some suggestions here. So we can use the fact that songs, we know that it's the 3rd element, which is index 2. So it would be songs, and then our square brackets 2. And then just as we have the square bracket notation here, you could do songs, square bracket 2, and then square bracket tempo. Okay. Any questions about that? So just like before with here, rather than song being our dictionary, songs at index 2 now acts as our dictionary name. So that's how we have these 2 square brackets. Okay. So now let's say I have a CSV file of the top 100 songs in 2018. This information is helpful, and I know that I can sort of see that I have my names and my tempos for these songs, but right now I'm not too sure how am I going to store this or use this information in, say, a Python program. So going back to what we've seen before with opening files, we can do something here with the syntax with open, this name of the file, as file. So what is this actually doing? We're opening up whatever file has this file name. So in this case, 2018 underscore top 100.csv. And we're opening this up as file. So this means that file is now the variable we're using to keep track of this file. It's pointing to whatever is returned as our opening of this file name. And so with this syntax, we can then use a method or something from our CSV library called dictReader. And so dictReader takes in a file, and you can store that in some variable called, say, file reader. So then we might be wondering, like, what does this dictReader function actually return to you? So it returns something very similar to what we were just looking at, where it's a list of dictionaries. So for every row in your file, we now see that it's been formatted as each row has its own dictionary, and each key corresponds with the headers or the field names, say, of the CSV. So file reader is going to contain this like list of dictionaries, and if you ever wanted to see the field names of the file reader, or in the CSV, what were my header row values, you can use .field names, which will return a list of those header values. Okay. So then with this file being opened, and with my file reader now containing a list of dictionaries, I could use that information and go row by row in my file reader. So looking at each dictionary and going row by row, I could do whatever I want to do with it. I could maybe get the name, I could get the tempo, and it will go line by line. Okay. So any questions about using files, opening files, working with dictionaries? So another thing to note here is that with this indentation syntax, we don't actually have to do the opening and closing manually anymore. And so the file will only be open for whatever code goes on in this with open block. And so you won't be able to access the file after the indented block of code. And yes, you would need to import CSV to use CSV dict reader. Okay. Someone's also asking about a certain notation. You can import a library as something. Yeah, so that's a certain syntax you can use if you wanted to reference a library in a different way. Okay, so let's get some practice with this. So I've downloaded this in advance, but let me clear my terminal here and open up playlist.py. Okay, so I have this code given to me already. We can see these are the two ways that I could import a certain library. So since I know I needed the getInt function, I just said, from CS50, import this function. I could do this also for CSV, but I'm just going to import CSV for now. And so the goal of this exercise, you saw here, is we want to build a playlist of popular songs within a tempo range. So we see here, we ask the user for a minimum tempo and a maximum tempo. And our goal is to fill up this playlist with the songs from this file that are within that tempo range that the user gave us. So if we look also at this CSV file, it looks similar to what we just saw before, where we have this first row indicating our field names. So we know that it's going to be a name and a tempo. And then we have the top 100 songs here. Okay. So if I want to read these songs from this file, first thing I'm going to need to do is actually open that file. So using that syntax we just saw, I can do open and then my file name. So in this case, I know it's called 2018 top100.csv. And I'm going to have that as a string. And I'm going to open that as, say, file. I could also name this something else, but we'll keep it as file for now. And so within this, I can use that dict reader function that we used. and I'm gonna store the output in a variable called a reader. Okay, so now I'm using my CSV library that I've imported here, and I'm using a specific function from it. And I'm going to read file, which has been opened. Okay. So if I just pause here and I printed out reader, we can get a sense of what this is going to look like. Oops. Playlist.py. Okay, so if I just tried to print out this reader itself, it's saying that this is a csv.dictReader object. So it's not able to tell me exactly what's inside of the object, but I know that the object contains a list of dictionaries. So if I loop through, say for each row in reader, and I printed out the row, now let's see. Okay, so now we see printed out every single row from our CSV file, but now formatted as a dictionary and each key value pair is based on what we saw in the CSV file, where we have the name and the tempo. Okay, so now that we have access to each song, how might we add it to playlist, but only if it's between a certain tempo range? So what might I do after here for each row? Yeah, so I'm looping through. Yeah, loop through each row in reader. So now that within this, I have access to the dictionary of my song. And I want to check if the tempo, is less than the maximum and more than the minimum. Okay, so how might I get tempo from the row I'm on? Let's say I want to store it in a variable called tempo. How might I get the tempo from the dictionary? If we recall, this row, each iteration of the loop, row is equal to like this dictionary, and then this dictionary, and so on. So I know I'm going to be using the row dictionary. How would I get the tempo from row? If this syntax is confusing, we can also rename this to song. Maybe that's more intuitive. So like we're looping through each song. And then we can use this syntax here where we're using the key. So, oops. Okay. So I'm getting this song, storing it in a variable called tempo. And then I want to compare this. I want to make sure that it's greater than the minimum tempo and that it's less than the maximum tempo. And let's say if it is, I'm just going to print for now and see if this does what I'm hoping it to. Okay, so let's clear and playlist.py. Someone is asking, so we could set this as less than or equal to, greater than or equal to. It's up to you based on your implementation. So let's go with that. Let's say my minimum tempo is 50, maximum is 100. Okay, what error are we getting here? So on line 14, we have This comparison is not supported between instances of string and int. So why might that be happening? Yeah, someone says tempo is a string. So since we have read our tempo from a CSV, in this CSV, even though they look like numbers, it's being treated as a string. And so what we can do, is like cast it. Since some of these tempos include decimal values, I'm gonna try casting it as a float. Okay, so if I try this again now, okay, now we see I'm getting the songs that are between a tempo of 50 and 100, which is great. Okay, instead of printing it now, I would like to add it to my playlist. So I can use the .append function that we saw earlier, and I'm just gonna append the song. So I'm gonna append the entire dictionary so that at the end of this, playlist is a list of all the dictionaries of songs that are between my specified tempo range. Okay. Yeah, someone says, should we use try or accept? Yeah, so when you're doing this sort of conversion here, that is a good thing to note that, maybe my tempo is not actually something that's being able to convert to a float, and that would give us an error. And so this would be a good instance of using try and accept. I think that's good intuition. I won't right now, just for the sake of time, but that's very good, like the right kind of thinking you should be doing when you're working on your problem set. Okay, so now I have this playlist list and I want to print out the song titles. What I could do here is loop through the songs in my playlist. And then for each one, I just want to print the name of the song. So how might I do that? Using my dictionary syntax that we've learned. Yeah, so I'm going to do the dictionary, square brackets, and then the name of the key, which in this case, my key is going to be name. Okay. So let me run this one final time. Python playlist. Okay. Say I only want songs from 70 to 80. Okay, so it just gives me 4 songs here. I could go ahead and double check if I wanted to that we could see the song is between 70 and 80, so is the song. So I think that worked the way we wanted it to. Okay, awesome. Any questions about what we just did here? Okay, so this was some good practice using CSVs and working with files, which is what you will be doing in the Python problem set, and working with the dict reader function as well. Okay. All right, well, that's the end of section 6 on Python. Thanks for your participation, and hopefully we'll see you here next week for SQL, where we dive into databases.